Hello everyone, I'm Mathieu Grob, Presales Manager at ViaGrade, and thank you for joining us today for our webinar about ride and handling applications with ViaGrade Driving Simulators. I will be your host today, and I will start with a short introduction about ViaGrade, who we are and what we want to develop in the simulation and simulator industry. And then I will show you how to use at best driving simulator technologies for ride and handling applications. So let's start. So today in the automotive industry, you all know that we face very serious challenges that are summarized as now. We have challenges from the market with less time and budget allowed for each project, from the product with more and more complexity with all, let's say, systems, ECUs in the vehicles today, and from the process with more and more validation required to validate, to ensure that every automotive product is safe and working as it tends to be. So the actual development process, as we know it, the traditional V-cycle development process, is not tailored for those new challenges. Typically, as you can see here, we have a two-phase development process. We start with the concept and the high-level design, typically with CAE engineers and virtual development, up to the detailed design, and then we start to build some components to test them, to assemble our automotive product, then to validate and test it on the track up to the final sign-off. The problem that we have here is that, first of all, it is quite slow, because when you develop new technology, you have to have a far more integrated development approach. Secondly, it's very difficult. We need, for example, to validate a new prototype, to know now more and more kilometers to validate it, and it's not always possible. We do not have the time of the facilities to do this. And finally, it's very expensive, because if you have a problem during the component testing or the validation, you have to go back to your high-level design or your detailed design process to start a new process of designing and changing a part, and it's very slow and expensive because you have to start all over again the V-cycle. So at ViaGrade, we propose you a different approach with this V-cycle. Typically with the, let's say, sequential development process that we have today, with CA engineers on the left of the V-cycle and test drivers and testing on the right, we want to narrow this V-cycle and to bridge the gap between the high-level design and the validation for a parallel development process where CAE engineers and test driver meet all together around the driving simulator. So you have basically an engineering center where you can tackle all the kind of disciplines, ride and handling, NVH, NDAS and autonomous vehicle, HMI or motorsport, with various environment, scenario, all kind of vehicle models, and test all your modeling plus prototyping with all together with your engineers and test driver in the same environment. So it's a shorter, you can achieve shorter development time with this collaborative engineering, and you have also tests performed far earlier in the development process, because right at the beginning with your virtual design, you are experimenting if your solution is working. So this is what we call bridging the gap between testing and simulation, because from a slow you go to an accelerated product development, because you have less prototype and you have a fast forward development process. From a difficult process, you go to easier system level validation, because all the systems you have designed and modeled can be tested right away in the driving simulator. And finally, from an expensive to an affordable development process, because you can test far earlier in the development process if your product will work as intended, and change it on the fly in the same day by a collaborative process between engineers and drivers. We can also, with this process, calculate measurable benefits. It's very easy. So you can reach a break-even point after your first investment in driving simulator technology. It's possible to calculate it and to achieve very measurable benefits very soon after your driving simulator installation and starting a virtual development. So what we want to achieve with this kind of process is to break the usual, classic approach of automotive development. So classic approach, as we described it before, was you dream your new automotive project, you design and make it, and then you try it and you see if it's living up to the design expectations that you had. We want to break this paradigm, and we want to give you the opportunity to try your vehicle right out of the first dream you have, or the first design. And so basically you can drive your prototype for a faster, easier development process, and then you can test and develop everything before building your first ever prototype on the track. To achieve this, we have developed at ViaGrade mainly three main components. First one, of course, is the software, where we have developed a complete environment and ecosystem of software to simulate all the aspects of your vehicle, up from the road up to coming back to the driver feedback. Of course, to link this with the software to be able to drive your prototypes, we have developed a whole lineup of different kind of simulators, all with different purposes and complementary use. And finally, to be sure that we are completely tailored to your needs, we can also do services to completely customize or adapt the solution to your need, so to develop a real virtual sign-off solution. And then it means that by doing this virtual sign-off solution process, we introduce innovative products with less time, less risk, and less cost. So there are very measurable benefits with this approach from our different customers, like Volvo, who said have reduced by 50% the time to market of the new XC60 SUV developed mainly in the driving simulator. 90% of the development is done on the simulator before the first prototype of the new Alfa Romeo Giulia was done on the road for Alfa Romeo. And finally, at NIO, they estimate that they had a 40% reduction of physical prototype on their new coming models. One testimony of one of our customers and partner, Multimatic, that from Lars Ogilvy, is that using those simulation tools, they are really prototyping and testing upfront just before even the first prototype is built. So let's listen to his
the application of the simulator and the offline tools with the ViaGrade products and the tie-ins to the MATLAB interfaces and all the products of these new cars. You have very complicated systems, and they need to interact all together. And in the end, with the shorter development cycle, you're not going to have a chance to do a lot of prototyping and testing with physical prototypes on the track. Using these tools, you can do that all up front, and the first prototype that's built is going to be very close to the final version of what you need.
So knowing that, now that you understand clearly what ViaGrade wants to develop and have developed to help you developing new cars, let's dig into our ride and handling specific development and application. So what is ride and handling? Why is ride and handling so important in the automotive industry? First of all, why ride and handling? It's a very important topic. I think you know that, but it's worth remembering it, because automotive product is a mix of opposite disciplines. All the disciplines we try to mix in an automotive product, all the different aspects are antagonists, and it's very difficult to obtain a well-balanced vehicle on all the different aspects. We can obtain extreme performance in one or two disciplines, but have a real balanced vehicle is a real challenge. And ride and handling are really direct opposites, because the setup of your vehicle you will achieve to have a very good handling vehicle will be totally opposite, for example, in terms of damping, or what you would have for a ride and comfort vehicle. For a ride and comfort vehicle, you will want to have very low damping to a very comfortable vehicle, or a very high damping for a good handling vehicle. It's the same, for example, when we talk about tires. A tire is a really big balance between all different performances, and having an automotive product that is both in terms of the car and the chassis and so on, plus the combination with tires that is meeting the expectation of ride and handling, is a very big challenge. You have to test upfront to understand all the different aspects you have to tune. So automotive product performance is always a balancing act in between different constraints and performances, and ride and handling balance is a crucial combination that we found in all automotive products. So how do we define ride and handling? We will tackle this topic as mainly speaking about frequency domain. So for us, ride and handling would be the low frequency band within about 0 to 40 Hertz. So let's say all the low frequency maneuvers up to, let's say, primary ride maneuvers. And this is where we will focus our attention today. So the challenges that present ride and handling tuning are find the best balance of vehicle performance, like suspension design and kinematics, mass distribution, spring and damper tuning, and we've seen just before, top mounts type, as you can see on, for example, this video of Volvo, where really designing the kinematics and all the dampers and the chassis balance is key in achieving those performance. But it's also having a strong link and collaboration with suppliers, for example, for tires, steering, because it's always a link between the chassis and the tires or other components that give the overall balance of the vehicle. To achieve that, ViaGrade has developed a complete driving simulator product line from, let's say, a more as pure engineering point of view to really driver-oriented systems. So here is our complete lineup that you can see here. So it starts with the desktop simulator. This is our most simple, accessible setup. That is really for engineering purposes. So it's really a gaming steering wheel with pedals, a wide screen, but with all ViaGrade software behind it, exactly the same software that we would find on any other of our biggest driving simulators. So you can design, test, and evaluate your modeling and vehicle model very easily with a very simple setup with the same software and simulation capabilities than all the other driving simulators. Here it's really not focused on drivers' usage, but more on engineers who want to test if their modeling is correct, if it's real time, if to debug some modeling aspects, and to check if the model is very good or is prepared correctly to go then on a bigger driving simulator to be evaluated in driving conditions. The next step is the compact simulator. The compact simulator is the first simulator where you have a more complete driver cockpit. You have a full assembly, steering wheel assembly with a big seat and a wider screen, so you have really a more realistic driving position. It's still not completely immersive enough for a real driver, because you have it's still a very simple setup, but it's super compact, and you have feedback like the steering wheel or the active systems like the seat or the belts that are in line with all the bigger simulators. So it's still a very engineering-oriented tool, but it's one that still the driver can have with realistic feedbacks from the steering wheel and the seat to start driving sessions. Then we have the static that is still not moving, as it is its name, and it's in between engineering and driving, because you have now a full cockpit, a wider screen for a completely immersive environment. And so the driver is really in a car with the field of view of the driver completely filled with the image of the simulation. And so it's exactly the same environment still at the compact, for example, but with a full immersive driving position and cockpit. And finally, the dynamic simulator that is really designed for the driver, because a driver will be efficient in a simulation environment if he can drive in real time. It's his working place, and the dynamic simulator is here to reproduce with the most fidelity possible the working place of a driver, so he can evaluate the design and, let's say, test and develop the design with the engineers in the same condition than on the track. So the dynamic simulator is really focused on giving the driver all the tools he needs to evaluate a design and give his feedback. So if we jump a little bit more in detail in the different setups, if we go back to a compact simulator, so you can see that first you have the cockpit that is with either a racing or a passenger seat, a full cylindrical screen for a wider field of view, a projector, 4K projector for the image, and the valve box is, let's say, optional. It's the system that powered or active system, because here you have, as detailed on the right, active seat and active belt that you can have that are here to give you haptic feedback with inflate cushions on the seat for lateral and vertical excitation, and the belts that give you the longitudinal braking feedback. You can have also active brake, optional, that is a braking system where you can exactly tune the response of the braking system to be exactly the same that in your car. For example, for the braking pedal stroke or stiffness and so on. And you have, as standard, the steering assembly that is with very high torque capabilities, so can reproduce very accurately the torque and the reaction torque of a rear car system. You can have also biotelemetry eye tracker system for more oriented physiological or psychological studies, and shakers at different corners of the chassis to give you high frequency feedback, plus of course speakers for the sound. If we now move to the static setup, in terms of hardware and software, it's exactly the same. The main thing here that is changing is that you have a wider screen, and you can have a full car, or let's say a full cockpit of a car that is far more immersive for the driver. So in terms of assembly, you have exactly the same thing: the steering assembly, the active systems, active brake, you can have biotelemetry eye trackers, the shakers and speakers. Here what you have more is also, for example, the rear side mirrors for better immersion, a bigger screen, so you have the realistic field of view with also with the cockpit of the car. So it's a real continuity between the compact and the static, same software, same hardware, enhanced immersion to go more on the driving oriented setup. Then to tackle our final dynamic aspect simulator, we have to talk about VIA-grade unique architecture. So VIA-grade has developed what we call our unique architecture, that is our dynamic driving simulator, driver in motion, what we call the DIM. So it's proprietary technology from VIA-grade with 9 degrees of freedom and a combination of 2 different stages for separation and parallel motion. So we have an upper part with 6 degrees of freedom and a lower part with 3 degrees of freedom. So why did we choose this architecture? Because the lower stage is designed to give you all the feedback you need for chassis dynamics. It's X, Y, and yaw response up to 5 Hz, and it's very adapt for all low dynamics maneuver, sliding dynamics, and so on. So as you can see, for lane change, for example, this stage will be dedicated to give you the low dynamic response of the maneuver. So you have a dedicated stage for this. Then the upper stage will be here to give you all the body dynamics feedback. So it can go in higher frequencies, up to 50 Hz, and give you higher frequency content, and it's very good for ride and comfort studies. So on this video, as you can see, if we ride on a track with a lot of bumps, holes, or waved concrete, the upper stage will give you all the high frequency content you need to evaluate and to feel all the aspects of the road and so on. So, and we can go up to more extended workspace and larger workspace to give you more capabilities, especially in steady state accelerations. And this is what we call our DIM 400, DIM cable simulator, where you can see you have in a very compact space a cable simulator that can give you a very high working space for more steady state acceleration and higher amplitude, especially for double lane change maneuvers or all maneuvers and studies that requires bigger workspaces. So ViaGrade has this unique architecture for driving simulators that makes it push it even higher the limits for driver immersion using dynamic driving simulators. So we have two architectures for our dynamic simulators that you have seen in our unique architecture. We have what we call the DIM 150 and DIM 250 that are the architecture we can see here with actuators. And we have also a motion platform with our supplier Saginomia. That is so the motion platform with the two stages that I detailed to you, so the tripod lower stage, low frequency, plus hexapod higher frequency. And so then you have, of course, all the bigger screen environment, 3 projectors, a big screen, and so on. And it's exactly, as you can see, the same list of hardware components apart from the platform than the previous simulators that we had. Of course, the big added value here is the motion platform to give all the feedback needed for the driver. So 150 is stand for 1.5 meters workspace usable in X and Y. Then we have the 250, same architecture but bigger workspace. So if you have less workspace constraint or want to have higher workspace movement, you can go up to 250 with this architecture. And finally, the DIM 400, so with this cable technology, with the same footprint that the DIM 250 gives you higher workspace capabilities, especially for needs like higher steady state acceleration or maneuvers that require higher workspace to give more feedback to the driver. Like for example, ADAS, autonomous vehicle studies, where you want to simulate longer exposure for the drivers. So in terms of frequency coverage, as we explained at the beginning, ViaGrade has developed different technologies to cover all the ride and handling frequency domain. So if we start from the very low frequency domain with the pure handling maneuver and especially the low dynamic maneuvers, we have our active technology that we discussed, so with active belts for the longitudinal feeling of braking, active seat with inflating cushions to give you the feeling where you are on the seat when turning laterally or vertically if you have excitation, and active brake to tune exactly the brake response like in your real vehicle. Then if we move up a bit in a higher frequency domain, so from 5 to 50 Hz, we have the DIM motion platform that with this double lower stage and upper stage technology allows to have the maximum feedback in all this range from 0 to 50 Hz, because you have really a parallel motion between high frequency on the upper stage and lower frequency in the lower stage. So you have a separation of frequency domain and no, let's say, antagonist movement of the two parts. So you have a very good combination here to have the best feedback possible in the 0 to 50 Hz range. Then for higher frequency feedback, we have shakers that we can put at the 4 corners of the simulator plus with the steering wheel for engine vibration that give you a feedback of what is going on with the wheels, the four wheels, and the chassis, and the extremity of the chassis, and with the engine vibrations. And so this is how we cover the spectrum from 0 to above around 50 Hz for ride and handling application. And of course, when you go higher, you have all the other technology with acoustic sim sound and VH simulators that are not our focus today. Another thing that is very important here, we are talking about hardware technology and our software that is out of the box covering all this spectrum. But as we have seen before, it's a matter of balancing the vehicle, but also other components. And one crucial component that we know is very important in ride and handling are the tires. So ViaGrade has developed a native interface for all the major tire models on the market at the moment, allowing to cover the entire ride and handling spectrum depending on your needs, specific needs, and so on. So the first one, like we can see here, is MegaRide, developed by MegaRide company that is from Napoli University. And it's covering mainly the handling part of the spectrum. Time Tire is the proprietary tire model from Michelin, also supported by ViaGrade, and it's also a thermomechanical model like MegaRide, covering mainly the handling application. Then you have the MF Tire and MF Swift tire modeling suite, distributed by Siemens. That is covering mainly with MF Tire the handling and with MF Swift the vibration ride frequency domain. Another tire model is CD Tire from the Fraunhofer Institute, basically that can also cover from handling and ride application. And at the end we have the F Tire tire model from Cosin Scientific Software that is more focused on vibration and ride and comfort applications. So now we will discover together. We can see that ViaGrade has developed an entire ecosystem of software and hardware that covers all the spectrum of applications and needs we need in the ride and handling applications. And now we will see, I will give you some examples of how our customers are using ViaGrade systems to achieve virtual sign-off and better automotive development. So let's start with Hyundai. So all the application cases I will show you now are available on our website viagrade.com, where we can register and connect to download the full papers, and also some videos of those papers are available on our ViaGrade channel, on ViaGrade channel, YouTube channel for ViaGrade. So you can either check the papers and also have a look to the video recording of the presentations. So what Hyundai achieved with this paper is to show that you can basically have a ride and handling application within the driving simulator. So what they wanted, the motivation, what they wanted to achieve is to, exactly as what we are discussing today, is how to have the best balance for the vehicle between the handling and the ride performance. So it's an optimization that you want to achieve, and how to achieve it in the better way, and how to have the most efficient way to find the best balance between ride and handling. So what they have done first, they wanted to be sure that the DIM here in the DIM 150 was able to give them the good feedback for the ride performance. So what they have done, they have replayed, measured in the vehicle a ride maneuver, and they have replayed it in the DIM to see if the bandwidth, the frequency bandwidth and content was enough in the DIM to work. This is what you can see on the right, that between 5 and 30 Hz, the rear vehicle and the D platform match almost perfectly. So the conclusion was that the driving simulator is a valuable tool for ride estimation. And then, so they started to work on this balance, using F-tire modeling for the road contact and the tire modeling to have enough frequency content to both tackle, let's say, lower frequency range and higher frequency range. They have also implemented their own damper model, so they will be able to evaluate if the damper design is good enough for ride and handling application, and also a temp mount model with our module MX mount for the engine mount, for example, to evaluate the vibrations coming from the system. And all this can be run real time in the simulator, and so the driver can evaluate in real time with modeling and all the characteristics of the vehicle if the balance for ride and handling is achieved, because he can drive either ride or handling scenario depending on what he wants to test. The second example is coming from Volvo, that is using their own DIM 150 for extensive virtual development, as we have already briefly discussed in the first part of this presentation. So Volvo is really in a way that they want to improve, not replace something in their development chain. They really want to improve how they made car and obtain a better product at the end of the development process. So they have done for ride and handling application here 3 different studies. The first one was on axle kinematics, second one on tire selection, and the third one on spring head tuning. So for axle kinematics, what Volvo has implemented is a Simulink Pro simulation model where they can live tune the kinematics of the car. And so with driving the simulator with the VIA-grade driving simulator, they can input in the simulation some tuning on different components of the powertrain, not the powertrain, the chassis, the roll bars, the kinematics, dampers. And so they can really change the behavior of the car live and evaluate the change on one lap of the driver, corner after corner. They can change the setup, and so it's a very fast and efficient way to test different settings for your kinematics and obtain the best balance at the end. So another aspect of the axle kinematics, they also tune a lot the rear of the car with the hardpoint location of the rear axle, and they test many different aspects and setups in the driving simulator to establish exactly the geometry and what they wanted to have in the final car, all that in the driving simulator. So they really design a lot of all their axle kinematics characteristics within the driving simulator before even building the first car. And here on this picture you can see it's a capture of the Volvo proving ground, because they have also modeled all the proving ground in the driving simulator, so they can really test in the conditions they know and have their own criteria also on the driving simulator. Another critical aspect that we discuss is tire development, especially, for example, for when you are developing electric vehicles. The center of gravity of the cars are lowered and a little bit shift on the back of the car. That is what Volvo is explaining it. So it put different aspects and constraints on the vehicle development and also on the tire selection. So here, instead of building a first prototype and trying to have different tire size, width, and types rolling in real life to try to understand which one is the best, they use CD tire modeling with the morphing tool to test different size, width, and so on, to determine which tire characteristic would be the best suited for the new car to come. And what they achieve is that the potential cost saving of $10 million have been achieved, because instead of building prototypes, going on the test track or on flat tracks to test the tires, trying to understand which characteristic is the best, they have established all this in the driving simulator, and so they have a clear idea of which tire characteristics they have to have at the end to obtain the good behavior. And then the last use case is the spring head tuning. So to improve the body motion of the production car, they have worked on the front bump stop and the spring head to tune them to obtain exactly the good behavior of the car. So you see they have really worked on different aspects of the car, all in the driving simulator. And for this particular spring head tuning use case, they estimated the time saved about 4 to 8 weeks in the development time. So here you can have at the end a car that is more refined, because in the same amount of time you can test more hypotheses, you can design in a better way your system and evaluate at the end the overall compromise and balance of the car. The last use case we have to present here is AMG with the DIM 250, and it's the more extreme let's say application case we have here, but it's also one that is really on target, because it's really what highlights really much how the driving simulator can be a powerful tool to evaluate different aspects. Here the challenge is gigantic, because with the Project One car, they want to be able to have a Formula One powertrain engine in a road car, homologated road car, and being able to use it every day, that the car is handling properly. And so the amount of tuning and refinement that you have to have in all the car systems is huge, from the electronics, the chassis, the powertrain, the tires. Everything needs a very dedicated attention. And for such a project, you can imagine the amount of time and testing that you can spend trying to tune every single aspect for the car to be as efficient on a Nürburgring Nordschleife lap time, and being able also to be really drivable and easy to ride on a normal road. So they use the DIM simulator to tune all the different car systems and have the better approach to the car design they want to obtain at the end. And what they have done, they have worked, for example, on the suspension and try to define the best geometry of suspension. So, for example, coming from ADAP's car to the VIA grade environment, they can export the geometry of the suspensions, and so test in a real driving condition on the simulator if this is giving the good behavior of the car, for example on the Nordschleife very demanding circuit. Controllers, as we said, for such a complicated car, you can imagine all the amount of electronics needed to control the car, all the systems, and to monitor what is going on, especially, for example, for the powertrain or all the electronic aids. So they can here, with model in the loop or software in the loop or hardware in the loop, introduce the real capabilities of the future real car in the driving simulators and test live driving it and see how the feedback that it gives to the driver. And of course, at the end, tire tuning, very important, here with the temp tire modeling from Michelin that has been used for tune the best tire solution for the needs of the car. All this have been done in the driving simulator before even a first prototype has been put on the road. So we have a very refined prototype that is coming at the end, that is maybe not even really a prototype, but already a first glimpse of what will be the production car. So here is a little video to explain a little bit more in images what AMG has achieved. So this is the image from the driving simulators on the Nordschleife, the Project One, being driven in the driving simulator. So I think you have seen in this video how impressive and immersive driving in the DIM 250 it is around the Nordschleife. You see at which speed you are going and how the driver is handling the car, and the platform is moving with the two stages we have introduced earlier on in the presentation, and how powerful this tool can be to really evaluate your future design. We are at the end of my presentation, so I hope you enjoyed it and it gave you enough insights of how ride and handling performance can be achieve even better, how a balance of the car in ride and handling performance can be achieved even better with ViaGrade driving simulator technology. If you want to contact me and start asking more questions to interactively interact and go in deeper detail, or start to configure your simulator needs, understand what you will need for your own applications, and calculate your return of investment, you can contact me at the email address here, mathieu.grob@viagrade.com, or visit our webpage, and you can have a lot of info on our website, and also request more detailed info if you want. Thanks for your attention. Thank you very much for attending this webinar. We hope to hear from you soon. Thanks a lot.